Okay, we're starting lesson 3-1, multiply greater numbers by powers of 10. I can use mental math to multiply a whole number by a power of 10. And in the solve and share today, at Izzy's party store, party invitations come in packs of 8. How many invitations are in 10 packs, 100 packs, and 1,000 packs? So we're multiplying by multiples of 10. So if you want to write out the equation, you would say 8 times 10 equals how many invitations? 8 times 100, 8 times 1,000, and so on. So 8 times 10, get your 8 times tables and your 10 times tables. 8 times 100, you can use a distributive property, remember. 8 times 1 is 8, and you can bring those two zeros over. 8 times 1 is 8, and you're bringing the 3 zeros over. And we're looking for a pattern there. And if you notice, as you increase by multiples of 10, you're going to have additional zeros. Your 8 is going to be in the tens here, it's in the hundreds here, and it's in the thousands here. So, and you can also use manipulatives. You can use your any kind of manipulative. And if you look here, each one of these little lines represents 10 little squares. So here's 8 times 10, and you can count that. 10, 20, 30, 40, 50, 60, 70, 80. Each of these is 100, so we have 800. So we said 100, 200, 300, 400, 500, 600, 700, 800. And each one of these cubes represents 1,000. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. Thank you cards come in packs of 12. How would you use place value? How would the model look different than the model above? Well, the model above, we're multiplying by 8. And in the look back, you're multiplying by 12. So how would it look different? Well, instead of 8, we'd be doing 12. 12 times 10, 12 times 100, 12 times 1,000. 12 times 10, remember, use distributive property. 12 times 1, bring your 0 over. 12 times 1, and bring 2 zeros over. 12 times 1, and bring 3 zeros over. Be careful. Common error is if you have, when we start doing some math, when you are multiplying as moving ahead, this is moving ahead. So if I have 5 times 20, I do 5 times 2. My distributive property is 10, and I'm going to bring 1 0 over. If I have 5 times 40, using my distributive property, 5 times 4 is 20, and I need to bring 1 0 over. Even though I have a 0 here, when I do 5 times 4, be careful. Remember, you've got to bring that other 0 over. That's just looking ahead at some common errors kids make. And we'll see that come up again, and I'll alert you to it again. Okay, so that was our solve and share. So we're looking for patterns. Next page. So you can watch the video, and the video will use the animation to explain the problem. And we'll go over it together here now, but you can also watch the video. How can you use patterns and mental math to multiply a whole number by a power of 10? Arnold read a newspaper article about how much garbage each person produces each week. How many pounds of garbage are produced each week by 10,000 people? People make lots of garbage, don't they? Patterns will help show you how to use mental math to multiply by powers of 10. Find 32 times 10,000 using place value relationships and look for patterns. So you know 32 times 1 is 32. 32 times 10 would be 320, and they're showing their zeros in red to help you out. 32 times 100 would be 3,200. 32 times 1,000 would be 32,000. 32 times 10,000 would be 32 10,000s, which would actually be 320,000. So 320,000 pounds of garbage are produced. And the shortcut rule down here, count the number of zeros in the power of 10, annex that number of zeros to the other factor to find the product. And you can look here very nicely, they're actually showing the exponents to help you out. Remember, we did this in chapter 1. So 1 can be shown as 10 to the 0 power. I know that's a little weird, but 10 can be shown as 10 to the first power because you're only multiplying it, you're only showing it one time. 100 is 10 to the second power, which would be written as, remember, 10 to the second power is the same as saying 10 times 10. The base is 10. The exponent tells you how many times you're going to repeat the factor, and you're always using multiplication. 10 to the third power, the base is 10. I'm going to repeat it 3 times, so that will be 1,000. This guy is 100. 10 to the fourth power, the base is 10. I'm repeating it 4 times. It's going to go right off the page. And I'm going to have 4 zeros. So that's a little review of exponents, and that will help you. Place value is very important when we're doing multiplication. You have to make sure you have everything in the right place or your numbers don't work. And it convinced me. Nellie says that the product of 60 times 1,000 is 60,000 because you annex 3 more zeros to 60. Kara says the answer is 6,000 because the answer should have only 3 zeros. And that's what I was talking about earlier. Be careful. Remember, using the distributive property, in this case, 60 times 1,000, I'm doing 60 times 1. So in solving a simpler problem, 60 times 1 is 60. And then I'm annexing 3 zeros. The 0 in the 60 does not count towards the annexing of 3 zeros. It's separate. So be careful. That is a common problem that kids make. They say, oh, there's already a 0 there. I only have to bring 2 over. But you don't. You have to bring all 3 over. Annex all 3 zeros. And doing a little guided practice here. How many zeros will there be in the product of 39 times 1,000? How many zeros will there be in the product of 50 times 1,000? And you, in the first one, 39 times 1,000, you're going to annex 3 zeros. 39 times 1 is 39, and then we're going to annex those 3 zeros. But be careful about what the question they're asking there. How many zeros will there be in the product of 50 times 1,000? Well, we know when we're multiplying by 1,000, we're going to annex 3 zeros. But remember, 50 actually has a 0 in it already. So we're actually going to be annexing, or we will, in our final answer is going to have more than 3 zeros. It will have 4 zeros because it will have the 0 that came from the 52. So 50 times 1, solving a simpler problem, is 50. And then we're going to annex our 3 zeros. So we have a total of 4 zeros in the second value. Explain how to find the product of 90 times 10 to the fourth power. So 10 to the fourth power is the same as saying 10,000. So 90 times 1 is 90. And this is going to tell me I need 4 zeros. So my final answer is going to be 900,000. So, and remember, when we're coming over here to the how do you know, we're just looking for some patterns again. 60 times 1 is 60. 60 times 10 is the same as 60 times 1, but you're adding another 0. 60 times 1,000 is the same as 60 times 1, but you're annexing 3 zeros. I'm getting them right here from my base 10 number. 60 times 10,000, 60 times 1, and then I have to annex 4 zeros. And make sure you get your commas in there where they belong. 13 times 10 to the 0. And this one is a sneaky one they threw in there. If you remember what 10 to the 0 means, it just means 1. That's an odd one. It just means 1. So 13 times 1 is 13. 13 times 10 to the first power means there's only one. 10 is only written one time, so it's like 13 times 10. Those are the ones that get a little tricky for kids. 13 times 10 to the second power is 13, and then we just put 2 zeros. To the third power, 13 and 3 zeros. To the third power, 13 and 4 zeros. Okay. Now you can work on your independent practice in your book. You can do the buddy work that's assigned to you. And don't forget, you've got, if you're doing the book work, you're working on, does not want to move over. You're finishing up this page here, page 115, and then you're moving on and doing problem solving on page 116. Try to do as many of these as you can. And the bottom ones, the Common Core assessment ones, those are the ones that are really helpful to help you with the math test. So I'm actually going to go over those with you right now. So even if you're doing these in the buddy work, please just pay attention for a minute. So choose all the equations that are true. So we want the answers that are true, the values that are true. I actually have to solve all of these to make sure they're correct. So I'm kind of going to ignore the answers that they have there. And I'm just going to say, I'm kind of like ignore that there. So 48 times 1,000, I'm going to write my answer to see if it matches. 48 times 1,000 would be, I'd make a 48 times 1 and then annex 3 zeros. Now, does that look the same? No, so that's not true. 48 times 10 to the second power, 48 times 1. And if it's to the second power, it's got 2 zeros. So is that one true? Yes. 48 times 10 to the fourth, 48 times 1, and then I want 4 zeros. And that one's right. 48 times 10 to the 3, that's a 48 and 3 zeros. Nope, that one's not right. And 48 times 10 to the 3, again, 48 and 3 zeros, and that one is right. Choose all the equations that are true. 20 times 100. I'm going to use a distributive property here. I'm doing 20 times 1, my 1 times tables. I can rock those. 20 times 1, and then I'm going to annex, bring over those 2 zeros. Does that look true? Is that the same? Yes. I'm going to do 20 times 1 is 20, and I want to do 3 zeros. 1, 2, 3. Put in my comma. Does that look correct? Yes, it does. 20 times 1,000 would be 20,000. Nope, that one's not right. 20 times 10. Remember, solve a simpler problem. 2 times 1, or 20 times 1 is 20, and I bring 1 zero over. Nope, that's only 2,000. And then 20 times 10 to the fifth. 20 times 1 is 20, and I want 5 zeros. 1, 2, 3, 4, 5. And that should be 2 million. That one's correct. And don't get tricked, because remember, 20 times 1 is 20. There's that 20 right there. Then we have to put 5 additional zeros. So my final answer is actually going to have 6 zeros, because there's 1 that comes from the 20 times 1. So don't forget about that. All right, there we go. That was lesson 3-1, mental math, using your 10 times tables. Hopefully you remember those.